Exercise 15 through 28 tell you to assume that the function f is one-to-one with a domain of negative infinity to positive infinity. If f inverse of 4 is equal to negative 7, then find f of negative 7. Remember what I told you earlier about inverses. Remember that I said if you have some f of x, to find the inverse, you just switch x and y. So that means f inverse of y will equal x. Like I said, you switch x and y. So f is an inverse of f inverse, so f of x is equal to y. So you see what you're doing? You're switching. So f inverse of 4 is equal to negative 7. That means f of negative 7 will equal 4. F inverse of negative 3 is equal to 5. That means that f of 5 is equal to negative 3. F inverse of c is equal to d means f of d is equal to c. If I have f of a is equal to b, then f inverse of b is equal to a. So I'm switching the x and the y around, or in this case in 20, the c and d around. Find f composite f inverse of 25 pi. Remember, if functions are inverses of each other, then f of g of x is equal to x, and also g of f of x is equal to x if g and f are inverses of each other. So I put something in the function, and then I put that result in the inverse, I get back to where I started from. So here I'm putting 25 pi in the inverse function, and then putting that result back into my function, which is inverse of the inverse function. So I end up with 25 pi. Number 24, 9,728. Putting 9,728 into my function f, putting that result into my f inverse function. Get back to where I started from. Show that f and g are inverses of each other by verifying that f of g of x is equal to x, and g of f of x is also equal to x. So I'm going to show that f of g of x, and there's a g of x, is equal to x, and I'm going to show that g of f of x, that's f of x, is also equal to x. So let me do that. My f function is 2 minus 3 times x. So that's what goes in for my x. 2 minus x over 3. 3's cancel out, and I end up with 2 minus the quantity 2 minus x. Distribute the negative, I get x. The next one, my g function, is 2 minus x over 3. This is what goes in for my x. Distribute your negative, and I end up with 2 minus 2 cancels out, so I end up with 3x over 3, which is x. So I just verified that they're inverses of each other. In exercise 29 to 34, show that f and g are inverses, so the same thing I want to do. So I want to find f of g of x, and then after that I want to find g of f of x. So let me do that. My f function is 3x plus 2 over x minus 1. So instead of x, I have x plus 2 over x minus 3. X plus 2 over x minus 3. So let me neaten that up. It's kind of messy. So if I multiply each side, top and bottom, by x plus 3 and distribute it to each term, let's see what happens. So when I distribute it to the first term, I end up with 3 times x plus 2. When I distribute it to the second term, I have plus 2. That's an x minus 3. Okay. Denominator, when I distribute it, I have x plus 2 minus an x minus 3. So let's neaten this up a little bit. And I have 3x plus 6 plus 2x minus 6 for my numerator. My denominator, I have x plus 2 minus x plus 3 for my denominator. I end up with 5x on the top. X's cancel out on the bottom. I have 5 on the bottom. Is equal to x. I'm halfway there. Now, I want to show the g of f of x, and there's f of x, is also equal to x. So my g function is x plus 2 over x minus 3. Again, I have 3x plus 2 over x minus 1, because I have g of x, I have g of 3x plus 2 over x minus 1. So that's what goes in. 4x. Neaten it up. So I'm multiplying top and bottom. And when I do that, I end up with 3x plus 2 plus 2 times x minus 1 over 3x plus 2 minus 3 times x minus 1. So let's neaten this up a little bit. I have 3x plus 2 plus 2x minus 2 on the top. Denominator, I have 3x plus 2 minus 3x plus 3. Numerator, I have 5x. Denominator, I have 5 is equal to x. Done. Next one. The graph of the function f is given. Sketch the graph of f inverse. So rotation on that line y equals x. So instead of the point right there that I have as like 1.5, 0, I will have about 0, 1.5. Okay? So these points down here will map over there. Okay? These points right here will map right there. These points up here, map kind of like that. And again, this will go here, and this will go here like this. So something like that. Graph the function, sketch the graph. So the point 6, 5 will now become 5, 6. So there's 5, 6 is almost off my graph. The point 2, 3 becomes 3, 2. The point negative 1, 2 becomes 2, negative 1. The point negative 3, negative 5 becomes negative 5, negative 3. And then connect my dots. That's the end of the dots though. Okay, so it ends where the dot is. Okay? So there's the graph of it. Determine algebraically whether the given function is 1-to-1. If it is 1-to-1, find its inverse, sketch the graph, give the domain and the intercepts for each 1-to-1 function and its inverse. So, what you do is you set 2x sub 1 plus 5 equals 2x sub 2 plus 5. Subtract 5 from each side. So I have 2x sub 1 is equal to 2x sub 2. Divide by 2. And I get x sub 1 is equal to x sub 2. So this is a one-to-one function. For 1x, there's 1y. For 1y, there's 1x. This is one-to-one. So let me graph the function. Just this function is given. It has a y-intercept of 5. 1, 2, 3, 4, 5. Okay. And it has a slope of 2. So slope of 2, slope of 2. Slope of 2 down 2 over 1. Okay. So if I was going to graph that, here I'm going to get a line and do it. It's probably a lot easier. So that's what the graph looks like approximately. Let me get it in the right spot though. Yeah, that's about right. Okay, so that's what the line looks like. Sketch the graph of the function and its inverse. Well, let's find the inverse. To find the inverse, remember, instead of y is equal to, it would be x is equal to 2y plus 5. So solve this for y. So I have x minus 5 is equal to 2y, divide by 2. And so my f inverse function, inverse, is equal to x minus 5 over 2. Okay? I personally think that the easiest way to graph this probably, for the inverse, is not graph f of x is x minus 5 over 2. I would use the graph I have here. And it said also, give the domain and intercepts. So here, my intercept is 0, 5. If I want to find my x-intercept, I know y is equal to 0. So to find my x-intercept, I solve that equation right there. So what I'll end up with is negative 5 halves, negative 2.5. So that's what this is, negative 5 halves, comma 0. Okay, so my inverse function, if I were going to graph it, instead of graphing 0, 5, I would graph the point 5, 0. Instead of graphing the point negative 5 halves, 0, I would graph the point 0, negative 5 halves, which is right about there. And then if I were going to find this graph, it would look something like, this. Oops. That's there. And right about there. Okay. And I hope you can see. Okay, so I graphed the two functions. I found the inverse. So here's the inverse. I found the intercepts. The intercepts for my graph. That's my f of x graph. The intercept, the y-intercept is 5. The x-intercept is negative 5 halves. My inverse function is the bottom one. And my x-intercept now is 5. And my y-intercept is negative 5 halves. So the x and y is changed. Sketch a graph, find its inverse on the same coordinates. Give the domain and intercepts for each one-to-one function. The domain for each function should be all real numbers. Next one, determine algebraically whether it's one-to-one. If it's one-to-one, find the inverse in the graph, and so forth. So, negative square root 9 minus x sub 1 squared. Set that equal to negative square root 9 minus x sub 2 squared. So solve the equation. I'm going to square each side. And when you square each side, then I end up with 9 minus x sub 1 squared is equal to 9 minus x sub 2 squared. Subtract 9 from each side. And I end up with negative x of 1 squared is equal to negative x of 2 squared. Multiply or divide by negative 1 makes them both positive. Take the square root of each side. And when I take the square root of each side, I have x of 1 is equal to plus or minus x of 2. Not 1 to 1. Not 1 to 1. Because x of 1 is not equal just to x of 2. It's equal to plus or minus x of 2. Next one, find the inverse of each function. Sketch the graph of the function and its inverse on the same coordinate axis. Notice x here, domain, is less than or equal to 0. So don't forget that. Okay, so it's not a whole parabola, it's half a parabola. Okay, and it's a parabola that opens down. So x squared, or negative x squared, looks like a parabola that opens down like that. But x is less than or equal to 0. So I have a point 0, 0. I have a point negative 1, negative 1. I have a point negative 2, negative 4, 3, 5, 6, 7, 8, 9, and so forth. So it looks something like this. So that's about what it looks like. Okay. Now, let's find the inverse. So to find the inverse, instead of y is equal to, it's x is equal to negative y squared. And remember, y now has to be less than or equal to 0. So solve the equation. Take your square root of each side. Actually, probably multiply or divide by negative 1 first. So negative x is equal to y squared. Take the square root of each side, and you have y is equal to plus or minus, but because y has to be less than equal to, it's not plus or minus, it's just minus. Okay? So there is my inverse function. Okay? And if I were going to graph that, I personally think the easiest way to do it is to just graph, where I graph 0, 0, switch of points, I still have 0, 0. Negative 1, negative 1, switch of points, I still have negative 1, negative 1. But negative 2, negative 4 now becomes negative 4, negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 3. So it looks something like, the inverse function looks something like this. Okay? And notice, it better be a reflection around this diagonal line here. And it is. That's the line y equals x. And it is a reflection around that. So I found the inverse of the function. I sketched a graph of the function. It's inverse on the same coordinate graph. Okay? And if I want to ask to find the domain here, you know that negative x has to be greater than or equal to 0. So what's in there has to be greater than or equal to 0. So x has to be less than or equal to 0. So I have a positive number under the radical. Didn't ask for the domain, but I gave it to you. Find the inverse of the function, sketch the graph of the function, and its inverse on the same coordinate axis. Okay, so this right here, equation is a parabola that opens up, and it's 5 up. 1, 2, 3, 4, 5. But it's only x is greater than 0, so it's 2, 3, 4. So it's something like this graph right here. So there's the graph. If I wanted to find the inverse, I would do x is equal to y squared plus 5. And now y has to be greater than or equal to 0. Solve the equation. Y minus 5 is equal to, or x minus 5 is equal to y squared. Take the square root of each side. So I have x minus 5 is equal to y. And it's plus or minus, but because y is greater than or equal to, it's just the plus. And if I were going to graph it, instead of graphing the point 0, 5 like I did with the original graph, I would graph the point 5, 0. 1, 2, 3, 4, 5, 0. Okay. Instead of graphing this point 1, 6, I would graph 6, 1. Instead of this point right here, up there, would be 2, so 2, 2, 3, 4 would be right there. So it looks something like that, the graph. So that's what the inverse looks like. 56, assume that the given function is 1 to 1. Find the inverse of the function, also the domain and the range of the function. So the inverse, x is equal to y plus 2 over y plus 1. Cross multiply, xy plus x is equal to y plus 2. Y is on the same side. Xy minus y is equal to 2 minus x. Factor out a y. Divide by x minus 1 on each side. And I end up with y is equal to 2 minus x over x minus 1. Domain of this, x cannot equal 1. Okay? So this is my inverse function. So assume the given function is 1 to 1. Find the inverse. Also find the domain and range of the given function. Well, the domain of the given function is x is not equal to negative 1. The range is the domain of the inverse function. So the range is x cannot equal to positive 1. Same thing here. Solve. Consider y equals as x is equal to. Cross multiply. Y is on the same side. Factor out a y. Divide through by x minus 1. So my inverse function is 3x minus 1 over x minus 1. The domain for this one, x cannot equal 1. So the range for my original function is x cannot equal 1. The domain is x is not equal to 3. That's all of the problems for now.